Alcohols are compounds that have the COH group of atoms, as I've shown here. We often use the symbol R for alkyl groups, and alcohols may have 1, 2, or 3 R groups, or these could all be H's. When they're all H's, we have CH3OH, methyl alcohol. When there's one alkyl group, we call these primary alcohols, often symbolized this way. When there are 2 alkyl groups, we call it a secondary alcohol. And when there are 3 alkyl groups, we call it a tertiary alcohol. And I want to mention that there's one special kind of structure that we don't call alcohols. When there's a 6-membered ring with alternating single and double bonds, we call these guys phenols. And they have their own special name because their chemistry is really quite different. So we'll put those aside for now and take those up when we take up aromatic compounds. In terms of physical properties, we see that alcohols have elevated boiling points. They are polar solvents. They have unusual solubilities in water. Hydrogen bonding holds molecules of alcohols tighter together than usual. So here's a molecule that includes an alkyl group. So here's the alkyl group of an alcohol, and here's the OH. Here's the alkyl group of another molecule of alcohol, and here's the OH. And the attraction that the hydrogen of one hydroxyl group has for the oxygen of another is very strong. So there are strong intermolecular forces which causes elevated boiling points. Not only do we see interactions between 2 molecules, but other molecules can interact as well. So another molecule of alcohol, here's the alkyl group, and the OH, can hydrogen bond with the oxygen of this first alcohol molecule. So we have 2 types of hydrogen bonding, one to the oxygen with the hydrogen of another molecule, one to the hydrogen with the oxygen of another molecule. All this makes for strong intermolecular interactions that hold molecules more tightly together and account for elevated boiling points. These bonds are quite polar because oxygen is more electronegative than carbon and hydrogen, and that causes a partial positive charge on the carbon and a partial negative charge on the oxygen, which accounts for the fact that these guys are polar solvents. And the unusual solubilities in water are accounted for by these same principles, including the hydrogen bonding. Take a look. This molecule of alcohol could hydrogen bond to 2 molecules of water, simply replacing the alkyl groups by H. Same type of hydrogen bonding arrangement. So alcohols have high solubility in water compared to other molecules their size. Alcohols have a wide variety of uses. They're intermediates in synthesis. You'll see that there are quite a few ways to use alcohols in synthesis. They're good solvents, used in home and in industry. They're good fuels. Methyl alcohol is used to keep little food burners going. Ethyl alcohol is added to a lot of gasoline to reduce our dependency on petroleum oil. And ethyl alcohol is the alcohol you drink. Isopropyl alcohol, also known as rubbing alcohol, is used as a disinfectant and a skin coolant. It evaporates readily and cools skin as it evaporates. Ethylene glycol and propylene glycol are antifreeze. These guys have interesting structures in that they have 2 hydroxyl groups next to each other. So this is ethylene glycol, 2 carbons. It's called that because it's made from ethylene. And this is propylene glycol. It has 3 carbons, made from propylene. And finally, it's interesting that several larger alcohols are used in flavors and fragrances. Geraniol, for instance, you could guess that comes from geraniums. Geraniol is used in a wide variety of perfumes. Let me just list the kinds of reactions we see for alcohols, and you'll see there's quite a variety. Substitution chemistry is really common, where the OH of an alcohol is replaced by a nucleophile. Dehydration is a classic reaction. Water is lost from adjacent carbons to make alkenes. Oxidation is common. An alcohol must have a hydrogen on the same carbon that has the OH. And under those conditions, Oxidation to make carbonyl compounds is common and important. Alcohols also act as acids. The proton of the hydroxyl group is lost. And alcohols also act as bases. Compounds that can act both as an acid and as a base are called amphoteric. So these are the kinds of reactions that are typical of alcohols. And in separate lectures, I'll talk about each one of them in more detail.